All right, 18.1 and 2. So we're looking at trig ratios, sine, cosine, and tangent. Our essential question is how can you use the sine, cosine, tangent ratios and their inverses in calculations involving right triangles? So previously, you guys did a discovery activity where we end up filling in a table with three different triangles. We saw they had the same angle measures, and we saw that when we took sine, cosine, and tangent of those different triangles, regardless of the size, that our value for sine, cosine, and tangent all were the same. So that led us to look at also some ratios of our sides. So as we compared some ratios, there is some variation based on specific measuring, but we did see that as we compared corresponding sides, all of these ratios were about the same, plus or minus, with generally within 1/1000th of a point. So which leads us to this idea that we have these ratios that we saw when we did similar triangles, that now leads us into here that we have corresponding sides together are going to have the same ratios, which leads us to these trig functions. So looking at sine, cosine, and tangent. So we're going to define sine, or sin, as sine, which sin is sin, but it is really short for sine, and is pronounced sine, not sin. Sin's what you deal with at church. Here we're going to deal with sine. And then cos, C-O-S, is not cos. It is short for cosine, which is pronounced cosine. And then tan, that's what you do during the summer. Since summer is coming to a close here, we're not dealing with tan anymore. We are dealing with tangent, okay, and that is pronounced tangent. Okay, so when we see those, these are abbreviations, but when we want to say the word, we don't say sin, we say sine. We don't say cos, we say cosine, and we don't say tan, we're going to say tangent. We're going to say the whole thing. Now, continuing with that, sine of any given angle is equal to opposite over hypotenuse. So we're looking at this symbol here is called theta. And it's just like x. It's a variable, and in math it's generally used for angles. So this is some angle, and then sine is defined as the opposite over the hypotenuse. And then as we look at cosine, cosine is now defined as the adjacent. Okay, and adjacent is the leg that is attached to theta. Opposite is the one that is opposite, so this side length here is not touching that there. And hypotenuse is always the longest side and is the one opposite your right angle. So cosine is now adjacent over hypotenuse. And then tangent now is the opposite, so the side that is not attached to the angle at all, over adjacent, which is the side leg attached to it. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. All right, so a little mnemonic device or memory tool to help you remind this. So ka, toa is kind of the mnemonic device to help you remember. And then so is sine, opposite, and then hypotenuse. Ca is cosine, and then adjacent, and hypotenuse. And then TOA is tangent, and then opposite, and then adjacent. So that's an easy way to remember what goes with what. So, ca, TOA will remind you sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, and tangent, opposite, adjacent. One of the biggest battles is just remembering what goes with what. Okay, so let's do a little practice on this problem here. So sine of A, so here's A. Remember, sine is opposite, so our opposite side is 18 over our hypotenuse, so our longest leg, and the side opposite the right angle is 30. And then cosine of A, so we're still dealing with A, but cosine is now adjacent, so that would be this leg here because this is always our hypotenuse. So cosine of A would be 24 over the hypotenuse, which is 30. And then tangent of A, so still same angle. We now have our opposite, which is 18, which we already saw from sine, over our hypotenuse, or sorry, our adjacent, which we already saw from cosine, so that is 18 over 24. Now, we're going to look at B, and so as we look at B, hypotenuse does not change, but our opposite now becomes this one over here because it's no longer attached to the angle, and this becomes our adjacent. This is a good tool that some of you may want to do is when you're doing a problem. Identify the angle you're working with, and then identify the sides as opposite, adjacent, hypotenuse. Sine of B, once you go ahead and figure out sine of B, cosine of B, and tangent of B, and we'll talk about those in class. All right, so let's look at another problem here. So sine of P, so we're looking at sine of P. Sine is going to be opposite over hypotenuse. Now in this case, we don't have our opposite, so we can find it. So using Pythagorean theorem, we have 7 squared plus b squared equals c squared. So that's 49 plus b squared equals 169. B squared now equals 120. And then we take the square root. And so then our opposite is going to be the square root of 120, which is going to be 10.95. So then my sine of P is going to be 10.95 over 13. Cosine, so this is now our adjacent, so 7 over 13. And now tangent of P is opposite, so tangent is going to be 10.95 over 7. And then sine of R, we're now going to be dealing with R down here. So that means our adjacent becomes our opposite now because it's no longer attached to our angle. Our opposite becomes our adjacent, and our hypotenuse is still and always will be our hypotenuse. So sine of r is now going to be 7 over 13. Cosine of r is going to be 10.95 over 13, and then tangent of r is going to be 7 over 10.95. All right, now we want to find the inverse. So we want to find the measure of angle P. So the measure of angle P, and we can use any of these trig functions since we know all the sides. I'm going to go back to the beginning where we didn't have QR. So we just had 7 and 13. So then angle P then is going to be cosine of angle P is now equal to, as we saw up there, 7 over 13. Then we do the inverse. And so inverse is cosine inverse of 7 over 13. Look on your calculator. Generally right above the cosine button will be a cosine to the -1. So you'll type that in, and then 7 divided by 13, and then enter. If we're not paying attention how our calculator is set up, most calculators will default to one answer. But if we're not paying attention, we'll get this as an answer, which is not technically correct because it's a form that we're not used to. So this is actually in radians, and what we're working is in degrees. So we gotta make sure our calculator's in degrees. Most calculators default to that. And so if we do that problem when it's in degrees, we then get 57.42 degrees. And then measure of angle R we can now find two ways. Since we know measure of angle P is 57.42 and measure of angle Q is 90. You can add those together and subtract from 180. Or, just for practice, we'll look at R here and set up a trig. So now, pretending we didn't know what QR is, we now have our opposite and our hypotenuse. So that is going to be sine of R equals 7 over 13. Same as with P, you're going to do the sine inverse of 7 over 13, which will equal 32.58. Which, when you add that with 57.42 plus 90, will give you 180. All right, so looking at a problem in terms of a real-world problem. So it's set up as, suppose a new regulation states that the maximum angle of a ramp for wheelchairs is 8 degrees. At least how long must the new ramp be rounded to the nearest tenth of a foot? So we want to find our ramp, which we'll call Z here. Here's our angle. So Z is opposite our right angle, so that's going to be our hypotenuse. And the side we know something about is this one over here. And relationship to angle A here, that is the opposite. So opposite and hypotenuse, think TOA. So we have opposite and hypotenuse, so we're going to use sine. So then sine of 8 equals my opposite, which is 2.3 over my hypotenuse, which is labeled as Z. And then to solve, multiply by Z, and we get Z sine of 8 equals 2.3 divided by sine of 8, and z equals 2.3 over sine of 8. Now, sine of 8 is an actual number. We could have found that earlier, but I like to have the calculator do all the work for me. So at this point, I'll just type in 2.3 divided by sine of 8, and that gives us z equals 16.526. And the problem, they said round to the nearest tenth of a foot, so we're going to round it to 16.5 feet. Word problem, we should have some kind of unit measure to it. All right, in order to meet safety guidelines, a roof contractor determines that she must place the base of her ladder 6 feet away from the house, make an angle of 76 degrees with the ground to the nearest tenth of a foot. How far above the ground is the eave of the roof? So what we want to do with this, anytime it's a word problem without a picture, we want to draw that diagram. So we have a house, and I'm just going to draw a side of it. She's going to place her ladder against that house, and then that distance, we're told, is 6 feet away from the house, and making an angle of 76 degrees. And to the nearest foot, how far above the ground is the eave of the roof? So we're looking for this distance here. So we'll call that x. So now as we look at this one, here's our angle we're working with. This is now our opposite. This is our adjacent. So going back up to our SOHCAHTOA, opposite and adjacent is tangent. So we're going to write tangent of 76 equals the opposite, which is x, over adjacent, which is 6. And then from there, go ahead and multiply both sides by 6. And 6 tangent of 76 equals x. In this case, our variable by itself, so we can go ahead and simplify for there. So 6 tangent of 76 now gives us x equals 24.06. And again, they wanted to the nearest tenth of a foot, so we're going to be 24.1 feet. All right, your homework is at the top of your notes. Work on that, and we'll go over this stuff at the next class period.